Hello everyone and welcome to my channel. In today's interesting class, we're going to talk about quadratic roots and we shall delve deeper into questions that are related to alpha and beta. Here we have a question before us that says, the two roots of the quadratic equation x squared plus 2x minus 3 is equal to 0 are denoted as alpha and beta. Find the quadratic equation with integer coefficients whose roots are alpha cubed beta plus 1 and alpha beta cubed plus 1. This question looks complicated and tricky, but trust me, we can always have our way around it because every problem has a solution. Now let's begin with this. I'm going to say solution. All right, when you solve this quadratic equation, you're going to get two solutions, right? You get two answers. So anytime you solve a quadratic equation, for example, as you have here, x squared plus 2x minus 3 is equal to 0. When you solve this problem, you're going to obtain two solutions. Now, we don't know what they are, but we can just name them alpha and beta, right? Now, to form a new quadratic equation, you must know this very formula here. And the formula is x squared minus sum of roots multiplied by x plus product of roots. I'm going to stop here as product is equal to 0. You need to know this very formula here because once you get your sum of roots from this two, okay, and your product of roots from this two as well, you are going to substitute them respectively into this formula, right? And with that, you can simplify and create your new equation. So every quadratic equation has a relationship with its, like every quadratic root or all quadratic roots, they have a relationship with their coefficients through this very formula. So once you know your sum of roots, once you know your product of roots, you can get the equation you are looking for. Now, all we have to do right now is to solve for the sum of roots and for the product of roots. Once you have these two values, we can now plug them in and solve for the new equation. Now, how do we begin with this? We are going to say for the sum, I will write for the sum of roots. The sum of roots is given as alpha plus beta, okay? We said that we do not know what the roots are, but let's call them alpha and the other beta, right? The formula for finding the sum of roots from this equation right here, we're going to begin from this. Remember, they gave us an existing equation, so we are going to use this equation to form a new quadratic equation, right? Now, let's first of all define our values. Our a is 1. The number in front of your x squared is 1. Your b is the number in front of x. So the coefficient of x is your b, and the number in front of x is what? A 2. And lastly, our c is the constant term which does not have an x attached to it. So whenever they ask for a constant, the constant is just a number that does not have a variable attached to it. The variable can be x or y. This -3 does not have an x term attached to it, so it's our variable. Now our c is equal to -3. Now let's find our sum of roots. The formula for finding the sum of roots is given as -b all over a, right? Now what I'll be here is 2. This now becomes -2 all over our a, as you can see here, is a 1, and this is equal to -2. This means that our alpha plus beta, which is the sum of the two roots, is -2. Now the next thing that we are going to do is to solve for the product of roots. I would say for the product of roots. The product of roots is given by the formula c over a, okay? Now what I'll say here, you need to memorize these formulas. For the sum, it's -b over a, and for the product, it's c over a. Let's plug in our values. What's our C? We have our C here to be -3. Hence, we have -3 as our C all over. What's our A? Our A is 1. This is all over 1. And we know that -3 divided by 1 is the same thing as -3. Now, with this information right now, what do? We are now going to form the new equation using this information. We are going to add these things up, right? They said find a new quadratic equation whose roots are this. So we are going to do the first step for the sum and the second step for the product. For the sum, we're going to add these two together. Have you seen? We have to add them together. And for the product, we are going to multiply the two together, right? That's the step to take, and that's how to do it. Like I said, and I repeat again, for the sum, add these two together. For the product, multiply them together. Then you plug in the sum here and the product here to get the new quadratic equation. Do you understand? Good. Now let's continue with the solution. So I'm going to say for the sum of the new equation which we are going to form. Now I'm going to copy this down. Here we have alpha. Let me use a black pen. Here we have alpha cubed beta plus 1, alpha cubed beta plus 1, beta plus 1. And then we have plus alpha beta cubed plus 1, right? Yes, we are correct with the copying. Now let's go ahead and work on this. Remember, we've already found our sum and our product. Our goal right now is not going to be how can I manipulate this expression right here in order to get something like alpha plus beta and alpha times beta, right? I'm supposed to put this here. Our alpha times beta is equal to -3. Yeah, so we are going to manipulate this in order to get the sum and the product. Remember, you cannot substitute a -2 and a -3 inside this unless you have your sum and your product. So we are going to either factorize this, simplify, or manipulate it in any way that we have to come up with this thing exactly and this one exactly right from these ones. Now, how can we do that? Well, since they're adding, let's now add them up. Okay, so here I'm going to pick the alpha cubed beta and the alpha beta cubed. I'll put them together. Therefore, we shall obtain alpha cubed beta plus alpha beta cubed. And now we have a 1 plus 1 plus 1 plus 1. Okay, this is the first one and this is the second one. I've added them together here. Now, here we have alpha cubed beta plus alpha beta cubed plus 2, right? Now, what do we do right now to this? How do we get the sum and the product from this expression? What do we do? Well, we have to factorize, right? If you look at this right now, we discover that we have alpha and beta appearing on both sides. So I'm going to pull out alpha and beta since it's common on both sides. If you pull out one alpha from 3, how many do you have left? 2. You have alpha squared, right? And then for the beta, if you remove beta from here, do you have any beta remaining? No. I'm just trying to show you how to pull out and factorize things, right? And now you have a plus remaining. If you remove an alpha from here, what do you have? No alpha left, right? And if you, since you have one beta pulled out already, if you remove 1 from 3, how many do you have left? We have 2 left, right? This now becomes beta squared. And then we have plus 2 left. Now look at this inside this bracket. This is an identity. It says that I'm going to write recall whenever you have alpha squared plus beta squared, right? This is equal to alpha plus beta all squared minus 2 alpha beta. I do not have enough time to start expanding this to show you how we came about this, but this alpha squared plus beta squared is equal to this. So if it's equal to this, I'm going to replace everything inside this bracket with this value. Do you understand? Now, if you follow me on my channel, I'm going to make more videos on how to derive these expressions so that you see how they work. Now, let me do the replacement. We have alpha, beta, multiplied by, I'm going to put this inside this bracket. And now we have alpha plus beta, all squared, minus 2 alpha beta. And then outside we have a plus 2. Now at this point, we have our sum. Have you seen the sum here? We have our product. We have our product. We can now go ahead and substitute these values here, which is for the sum. This is the sum and this is the product into this formula. Okay, that's the idea. Now let's plug in and solve. So our sum, we have it as -2, and our product is a -3, right? So I'm going to put a -3 here. You know, you've seen that our alpha times beta is -3. So wherever I see alpha beta or alpha times beta, I'll put a -3. Here we have -3, open bracket. Our sum is -2. This now becomes -2 all squared minus 2. And here we have our product again, which is a -3. And then outside we have a plus 2, right? Let's simplify this. We have -3 outside the bracket. -2 squared is a 4. Now, -2 times -3 will give you a plus 6. And outside the bracket, you still have your plus 2. Let's add what is in the bracket. -3. 4 plus 6 will give you a 10. And outside the bracket, you still have your plus 2. Now, -3 times 10 will give you -30 plus 2. And then -30 plus 2 is equal to -28. So this means that for the sum of the new quadratic equation, the value is -28, right? Now, let me write it down here. So here we mean that alpha cubed beta plus 1 plus alpha beta cubed plus 1 is equal to -28. We keep this value aside until when it is time to plug it and solve. Now we are done for the sum. Remember that we are going to substitute it into here for the new equation. Now let's go ahead and solve for the product. I'm going to write for the product of roots for the new equation. All right. Now, let's go ahead and solve for the product. Remember that the formula which they gave to us was alpha cubed beta plus 1. And then we have again alpha beta cubed plus 1. Now, to find a product, we have to multiply them together, okay? We need to multiply these two together. Now, let's do the multiplication. We have here to be alpha cubed beta plus 1. And then we have alpha beta cubed plus 1. Now, let's multiply them together to get the product of the new equation, product of roots for the new equation. Alpha cubed beta times alpha beta cubed. Okay, let's do it this way. Alpha cubed times alpha will give you alpha to the power of 4. Now, beta times beta cubed will give you beta to the power of 4. Okay, so when you multiply them together, you have alpha cubed beta times alpha beta cubed will give you alpha to the power of 4, beta to the power of 4. Now, let's multiply alpha cubed beta times 1 will give you alpha cubed beta, right? Now the next one is 1 times alpha beta cubed. You also have the same value, which is alpha beta cubed. Then 1 times 1 will give you 1, okay? Just like we did for the last one. Remember that we're looking for we're looking for the sum and the product, which means that we must manipulate this expression here to get something that looks like alpha times beta and alpha plus beta. They must be complete right here before we can substitute and start solving. Now, what do we do to this expression right here? We can go ahead and factorize it, right? Because I've seen that alpha and beta are common on almost all terms. So I'll pull out alpha, and then I'll also pull out a beta. If you factorize this right now, if you remove one alpha from 4, how many remains? You have a 3, alpha cubed. If you remove one beta from 4, how many remains? Beta cubed. Okay, that's how to factorize it. Now you have your plus. If you remove one alpha from 3 alpha, how many remains? We have a 2, alpha squared. If you remove beta from the only beta here, how many remains? None. So no beta remains. You put your plus. And from right here, if you remove one alpha from the only alpha here, how many remains? None. If you remove one beta from the 3, how many remains? You have a 2. Okay. You have a 2. This is squared. Okay. And then outside, what do you have? Plus 1. All right. Now let's continue this here. So if you decide to multiply this alpha, beta by everything inside this bracket, you will still get the original expression back, all right, which is this one here. You can try it out at your convenience to check and see what you will obtain. Now let's simplify the bracket further. Outside we have alpha, beta, open bracket. Remember, this alpha cubed, beta cubed can be written as alpha, beta cubed, right? From the laws of exponents, if we have something like, let's say alpha, beta to the power of 3, this can be written as, since they are multiplying inside, you can distribute the powers inside and you'll be left with alpha cubed, beta cubed, right? So that's based on the laws of exponents or based on the laws of indices. So in the same way, we have written alpha cubed, beta cubed into alpha, beta, all in bracket cubed, plus. Now, remember the last time from our last problem, which is a sum, we say that whenever you see alpha squared plus beta squared, it is equal to alpha plus beta whole squared minus 2 alpha beta, right? Now, we have also seen it here again. Here we have alpha squared plus beta squared. Now, I'm also going to rewrite it as, this is open bracket, alpha plus beta all squared minus 2 alpha beta. It's actually an identity, and it means that wherever you see alpha squared plus beta squared, you can simply replace it with alpha plus beta whole squared minus 2 alpha beta, right? Good. Now, let's continue with the solution. As you can see right here, we now have our product. We have our sum, and we have our product, plus our product outside. So everything is complete. We can now go ahead and substitute and solve for the product of the new roots. Okay. Now let's continue. What did we have? What did we get as our product? We got -3 as our product, and we also got -2 as our sum. So wherever we see the product, we're going to put -3. Now let's do just that. Here we have a -3, and outside, inside the bracket, we have the sum, the product again, which is -3. Now this one has to be cubed, plus here we have our sum, which is a -2. -2, we square it, minus 2, and what's our product again? -3. And then outside the bracket we have a +1. Now let's continue. Let's simplify what's inside the bracket before we can go ahead and multiply with what's outside. We have a -3. Now -3 squared, -3 cubed will give you a -27 plus. So here -2 squared will give you a 4, and then -2 times -3 is a +6 plus 1, right? The +1 is still outside. Now let's simplify what's inside this very bracket. Outside we have a -3, And inside the bracket, we have 4 plus 6 will give you a 10. Negative 27 plus 10. And outside you have a plus 1. Now, negative 3. Inside the bracket, you have negative 27 plus 10, which will give you a negative 17. Okay. And then you have plus 1. Okay. Now, let's continue with the simplification. Negative 3 times negative 17. 3 times 17 will give you 51. So here we have 51 plus 1 is equal to what? 52. Now, this means that the product of the new roots, okay, which is alpha cubed beta plus 1 multiplied by alpha beta cubed plus 1 is equal to 52. Okay, now we have the sum and we have the product. What next do we do with this to create a new equation? We are going to substitute it into this very formula and then create our new equation. Like I said, this is a formula you need whenever you want to create a new quadratic equation. Don't play with it. Don't forget it. It's really very important. Now, let's go ahead and solve. So now we say, I'm going to copy down the sum. So sum of new equation is equal to negative 28 as we got, while the product is equal to, here we have it as 52. Now what do we do next? We now write, we say x squared minus, so what is the new equation? The new the sum of the new equation is giving us alpha cubed beta plus 1. Okay, and let me put this in a square bracket. All right, so plus 1, and then we have plus alpha beta cubed plus 1, right? So this is for the sum, and it's multiplied by x, right? Now, for the product, okay, we say plus. What next? Here we have alpha squared beta, okay, sorry, alpha cubed beta plus 1, right? And then we multiply it with the next one, which is alpha beta cubed plus 1. And then we close our bracket. This is equal to what? 0. This is what we're looking for. So now, wherever we see all this right now, we substitute our sum and multiply it by x, and the product, okay, we also substitute here and then simplify to get a new quadratic equation. Now let's continue. Here we say x squared minus, what is the sum? The sum is negative 28. So we write negative 28 multiplied by x plus. For the product, what did we get? 52. 52 is equal to 0. Let's now simplify. Here we have x squared. Negative times negative will give you a plus. This now becomes 28 times x will give you 28x plus 52 is equal to 0. This is a new quadratic equation that we are looking for. And here is a solution to this very problem. Let me write it nicely so that you can understand better. Here, the new equation is x squared plus 28x plus 52 is equal to 0. This is a solution, and here is how to solve this very problem. So next time you are asked to find the root of a quadratic equation, a new quadratic equation given an existing equation like this one here, do it this way and you get the answer correctly. Thank you so much for being there. and see you in the next video.